Okay, so to sum up, UDP protocol is unreliable, but TCP protocol is reliable. So we talked about how TCP breaks package into smaller packets and send them over the network. And for each package, the receiving side should acknowledge that they received actually this package. And they will use sequence number to figure out in which order they need to show the data. So before if you are using TCP protocol, before even starting to exchange some information, you need to establish a connection between you and your another party. Okay. To establish a connection, there is very famous stuff which is called TCP handshake. TCP handshake is something like this. For example, the boy wants to send a message to girl. First, boy needs to ensure that this girl is okay and she's alive. Okay. The boy will say, hello, are you okay? I want to prepare to send you some message. Can you receive it? Are you able to receive it? And the girl will receive, yes, I'm okay, and will ask the same questions. I will also respond you back, are you able to process this message? I don't know. Boy will also, girl will also acknowledge, will also ask the same question. Then boy will answer girl's question, and this three message we call TCP handshake. Sometimes, actually not sometimes, usually they call it TCP three-way handshake. First message, we call it SYN, which you can just understand as synchronization between them. They just make sure that both of them are the same page. And then the girl needs to send ACK. It means that I acknowledge that we are on the same page, but girl also asks the question, right? Girl also asks the same question to boy, if the boy is also a good boy. And then boy needs to answer to that question. For that reason, boy needs to acknowledge to that question. So we call this three-way handshake: SYN, ACK-SYN, and ACK. Usually, we have a client, we have server. This is called client-server model, where any party which requests for data, it's client. For example, if WhatsApp have server, you send and receive some information, and you're the client who's using this service, right? A server usually provides some data. For example, if I wait for a message from my friend, this message will probably come from the server, because server is usually provide some data. And actually, this is what happens when you let's say visit to facebook.com. Facebook, on the web, we usually use HTTP protocol, which we will talk about next lecture. And HTTP is happens over TCP. For example, before actually receiving the web page, your device actually sends SYN, and Facebook sends SYN ACK. Your device sends ACK. Then they agree that okay, we can communicate. Then server starts the HTML, CSS files, sends to you, and breaks down all the files in the package and sends to you, and they check the sequence number. I don't know, a lot of stuff happens, then you see the page, okay? This is what happens. We will talk about that as well in next lecture. Okay, so this is how TCP works. For UDP, there isn't something like this. There isn't anything called UDP handshake. There is only TCP, because TCP very reliable, just makes sure that everyone is okay and everyone received the message. Okay, usually programs utilize some object, let's say, to communicate over the network. Okay, we call those object sockets. Socket is just an object inside our program that we can use this object to send and receive some information over the network in any program. You might write C++, you might write Python, you might write, I don't know, anything Java, Go, anything. You need, all of these programs have implementation of a socket, which will enable you to write some code that actually sends and receives some data. Usually inside the programs, we have like TCP socket, which is a socket that uses TCP protocol. We also have UDP socket, which is a socket that uses UDP protocol. We can actually, in Python, if you want to create a socket, you can just search for Python socket, and you will get this documentation about socket. Like, I don't know if they have examples. I hope they do. Why they don't? Okay. For example, you need to import socket object to create a socket that you want to interchange some information over the network. Let's say send we don't have much examples. Okay, this is some good example. So I write, let's say I write a program like Zoom. Zoom is just a program which is written by a bunch of developers. They create a socket, and then they need to assign a port number to that socket. Okay, where we send this packet from and where should we receive this packet to. I will open a Python file, which I will import a this code is already written. You don't need to just memorize it. You can try writing it at home just by looking at the code. But let's just go over this code line by line. I created two files. One is called UDP client. One is called UDP server. The server will listen for some message and will respond to that message. And the client will just send a message. Okay. Let's see what the server does. Server does, this imports object we call socket, and it creates an instance of that object. You can think of a socket as a blueprint, for example, a template. You need to create actual version of that socket from the template. So this is that template, and this is that actual object. Okay, so we create a socket, and then we pass a parameter which is called sock dgram. Dgram stands for datagram, which means that this is UDP socket. UDP, you remember UDP stands for user datagram protocol. This passing here sock dgram, it means that it's UDP socket.
What does it mean, dgram?
Open for datagram, but I don't know what datagram means. It's just a name, maybe.
Like, why Instagram calls Instagram?
It's a good philosophical question.
And also Telegram.
Let's call it datagram. I don't know, we can search why Instagram uses gram. Someone actually asked. Instant Telegram, it's something about Instagram. Okay, sounds weird. And I don't really know the reason why they call it gram. Okay. Actually, Telegram is something physical that we send over. For example, if I sent you a message like 100 years ago, I used the Telegram.
Yeah.
They used that word. They usually take this stuff from physical world and convert it to software or virtual stuff. Okay, so this is a datagram. So this is a UDP socket. I will call here that this is a UDP, a socket which uses a UDP protocol. Okay, it's a socket which uses UDP protocol. And then I need to assign a port number to this socket, to which port it should send and receive data. I just write like 5 5s. It doesn't matter. You can write any other port number, which should be in this range that I told you. Then I need to check my IP address. I will go to my settings, Wi-Fi, then details. My IP address is 1249. My IP address is this one. Okay. This is my IP address. So then I will just print a message that my UDP server is running on port, this port. Okay, I will just print this message that it actually started. Then what I need to do, I need to listen. Let's say I want to listen for some message, okay? For example, Facebook has a server that actually listens for a lot of messages. For example, I enter to Facebook, you enter to Facebook, I don't know, the other guy enters to Facebook. Facebook actually listens for that message, okay? Whenever it gets that message, it immediately responds. Actually, listening is just while true. Just you infinitely inside the loop, you just check. Did I receive the data? Did I receive the data? Did I receive the data? Did I receive the data? This is what we call listening. Okay. For that reason, I wrote a while true. And this line means that I will receive 124 bytes from this port, I don't know, from this device, okay? Whatever data I receive, I will just get 120 bytes. It doesn't matter, you can write any number here, but they usually put some numbers that are power of 2s. Okay, in receive from function in Python will return as a tuple. The first part of this tuple is message, what we received. And the second part of the tuple is address, like who sent the message, IP address and the port, whoever sent me the message. And then I print the message. Because this message is byte, I need to convert it to string. I then also print the address, like IP address, also the port. I add this colon in between them. And then I respond to that address. So I respond to that address, the same address, which sent me the message. I send salam, ben UDP server'e. Let's call this no. So I receive a message, I print the message and send the address, and I respond back. So send to means send, receive from means just receive the data, okay? But I do it instantly, I never stop, I just do it instantly. Let's run this UDP, the program which is called UDP server, okay? I write Python 3 UDP server.py. UDP server started and I run here like UDP server is running on this port number. If I go to my activity monitor inside Mac, let's wait for it to come to itself. Where is this Python? We will probably see this Python somewhere here. Maybe let's look at CPU. I don't see. Okay, let's.
Yeşil projeler.
Okay.
Aslında bunu yani ben olumsuz koyduğumuz mesela. Yani bunların aslında bunlar bu üniversitede mesela tam ki AI okuyanlar ya da information technology okuyanlar veya cybersecurity okuyanlar bunların nasıl orada kesiliyor yoksa orada buradan başlayıp ama öyle değil.
Kesilir. Daha detallı kesin. Hatta orada kitabdan 5 ay arasında kesilsen diyor. Yalnız burada bir ay içinde hamısından danışır. Ama orada mesela tək networkingdən 5 ay danışacaqsın. Allah belə lazımsız detallardan kimi girəcək.
Mesela dediğim gibi mesela network teknoloji uygulaması diyelim. Yani biraz gelmişken de farklı unutmam mesela. Ama yani en azından dediğimiz bir sürü şeyi bağlayabilirim.
Ama IT-də oxumaq istəyirsənsə, yəni hamısını keçəcəksən təzədən.
Ben AI konuşuyorum. AI içinde Almanya'da tersi tarafının birisinin sayısı yarı bir yer için. Bunlar da toplarlar. Mesela Technical University of var.
Aha.
Sonra Karlsruhe Institute of Technology var. Ve daha Aachen da var. Bu da çok güçlerinden istiyorum. Bilmiyorum o verim muhtesi verilmiyorsun. Bundan nasıl farklılar Aachen bazılarında onu görmedim. İyi ve AI düşüncesine yoktu. Çünkü AI çok yaratmazsa bir de değişik davranışını yapıyor. Amerika'da biliyor musun? Ama Amerika'da böyle değişik davranışını. Spesifik bir şey. Sen AI'yle bazı değil. Yani yapabilirsen, siz bilirsen, sebep pardon, sen psikolog, sen verirsen de var. Sen AI var mı diye.
Məncə adamlar olur. Elə adam var ki, computer science verən də proqramlaşdırma öyrənir, gedir industry tərəfə, sırf pul qazanmaq üçün. Elə adam da olur akademik tərəfə gedir. PhD, niyə işləyirəm, research. AI tərəfə gedəndən sonra akademik adamlar olur məncə.
Çünkü base bilme, skills bilme ondan sonra her yere gidiyorlar. Spesifik projeler istisna.
Okay, so I run this command which was called lsolve just to see which processors are using which ports. I ran my UDP server which I wrote in Python. It is, as we told, it's just while true. While true is receiving data and sending response. But it hasn't received any data yet because I didn't send any data to it. Okay. If I look at my terminal, I see that there is a Python. Let's just zoom it somehow. Okay. There is a program which is called Python. Okay, this is this one. Okay. This Python process is using UDP protocol. Okay, UDP protocol, and it's listening to this port. Listening means just as while true, it's just checking this port. Is there a data? Is there a data? Is there a data? Is there a data? It's while true, it's just checking this port. Okay, it's just doing this, and if I open my terminal, it's just, you see, it's not stopped. If I want to stop, I can press Ctrl+C, and this will stop. But it will never stop because it's in while true. It's listening, waiting for connections. Then I have another program here, which is called UDP client. Okay. Which is, as before, we create a UDP socket. Okay. What was the IP address? Let's check this again. Okay. So creates a UDP socket and sends surprised MF, which is a question, to this IP address and to this port. Who is listening to this IP address on this port? On this port, my UDP server is listening to that port. Like when whoever sends the message, he will get the message and respond the message with that message. So this my UDP client. What I do, I just send a message and I receive the response and print my response, whatever server responded to me with. Okay, so I open another terminal because on this terminal, my UDP server is running. If I run my UDP client, UDP client, Pi, I received a message, no MF. And this is the person who sent me the message. Okay, who said me no MF? It was the server. Okay, server received the message, surprised MF, and sender was this. You see this port number. The port number, actually, we didn't write anywhere here. This port number is assigned to it by my device. It's called ephemeral port, so it's just temporary. We will assign it and delete. Okay. But for the server, it's not ephemeral because I assigned it. Well, if I can send the message again, let's send another message. Why not MF? Let's send another message, and the server will receive another message. Why not MF? And this sender is again the same IP address but different port, because like we created another process. Like each time I run this program, I create new process. Okay, this new process has a port number, and then this port number is just removed. That's why we call it ephemeral, which means temporary. So a nice thing to do here, let's convert this program into some interactive program. I can write some message and send it. Okay. What I do, I will cut this here. I will write while true. Instead of let's call this instead of sending just this MF, I will get user input. Okay. I will get user input. Whatever user wrote in the input, I will send this message. And the reason why I use str.encode here, because I don't send string over network, I send bytes over the network. This encode function is just takes string and returns me array of bytes. Okay, so whenever I convert this program to this with while true, I get user input and I send the message. Let's do it like this. Okay. Hello. How are you? Okay. What the hell? Like each time I send another message and server responds me no MF. Let's actually convert it to string because it's not bytes. Hello. No MF. Why is still not okay, that doesn't matter. Let's do something interesting. I will copy this message, the whole file, and I will send this file to you. Copy this file, create a new Python file. You can call it anything you want. Just run this file. You can do it right now. Let's try if I receive your message. Okay, my UDP server is listening to my IP address and this 555 port. Okay, and if you run this program on your computer, you will send a message to my IP address because I wrote my IP address there. Also, this 55555 port. This package will be received by my device and my device will forward it to this Python program, which is listening to that port. Here, someone wrote hello, and your IP address is this 1.3, and your port is this number. This is the same person, probably. Without remember your name correctly. Still the same person sending the password IP address and the password report. Here is how your message. This is Murat's IP address inside this network, and this is channel IP address inside this network. And this are your port numbers, which are assigned to your process by operating system. Okay, which we call ephemeral port. If you stop this process with Control-C, and you run it again, you will have another port number. But your IP address will stay same. While IP address stays same, because you are still connected to context network. If you disconnect and connect, chances are you will have different IP address, but you might have the same. It's not for sure.
So what if I write Murat's IP address?
You will not receive it.
Why?
Your port number is received.
Port number is
Okay, in the same part, write Murat's IP address. Just try. Murat's IP address is 1.3. Right? The beginning is same, but the rest is 1.3. Because on Murat's computer, no one is listening for your message. You can just try it, and maybe you will have some error, like no one is listening for that message, no one received that message. But because on my IP address, on this 5555 port, there is a Python program that is running, instantly checking this if they receive the message. This is very basic form of client-server model. This is the basic stuff that is happening. That is happening with everybody. Whenever you send a message to the network, however, you chat, you call. Now you can also send and receive some pictures through this stuff. Like this is very low level. It's usually easy to send and receive videos and pictures, but this stuff is very, I think, very low level. I think it's hard. Okay. Also provided by Google. I don't know if they have some 7-day trials or not, if you don't want to pay money. Or some people really get, I don't know, they write a lot of stuff and get financial aid if you don't want to pay. I know actually some people who can pay, but they don't pay. They just ask for financial aid. But okay, this is a very nice and interesting course provided by Google. You can also watch and share the certificate on LinkedIn somewhere, put it on CV.
How long is it?
It's actually not very long. It's not long. It's 27 hours, but it's not 27 hours of videos, right? There are some quizzes, there are some stuff that they overestimate, for example. And maybe the quiz you can pass in 5 minutes, but they put 15 minutes there. So this is some interesting course that you can watch, but it's interesting, right? It's not boring. About Python, there are a lot of stuff. One that which is free, I showed you this program Viz. I think that was this program Viz. You can go here, you can learn Python. They have like a lot of stuff, a lot of topics here. You can read, also watch videos. If you don't want to hear the Indian accent of theirs, like don't watch, just read. Yes. I think there is also one YouTuber which is called Mosh Hamadani. He doesn't have weird accent, but he has a lot of courses like Python tutorial, 6 hours for fully beginners. If you have like patience, free code camp have a lot of interesting Python tutorials, like REST API automation. Some of them are advanced, but for example, this Learn Python is 4 hours, teaches everything related to Python for beginners. Okay. I don't know if we should talk about HTTP protocol. Let's just briefly talk about HTTP protocol because we have some time. But the next lecture, of course, we will dive deep into HTTP protocol. Okay. So here, like on Ethernet protocol, we have what? Like we have a MAC address. On network layer, we have IP address. On transport layer, we have port numbers. On application layer, we don't have just one protocol. We have like many protocols. You can even create your own application layer protocol. HTTP is one of the most popular protocols that actually everything over the internet, almost everything over the internet goes through HTTP protocol. HTTP stands for Hypertext Transfer Protocol. Hypertext Transfer Protocol. Okay. Hypertext means a text which contains links. For example, HTML page. Well, for example, I go to facebook.com. It's a text which contains links. For example, if I click here, this is a link. If I click here, this is a link. I don't know if I click here, this is a link. Hypertext basically means HTML. Okay. So initially, this was meant to transfer this HTML page over the network. That's why this is called Hypertext Transfer Protocol. But nowadays, they don't only transfer HTML, they transfer a lot of formats of data. Whenever you enter a website, you actually make an HTTP request, and which happens over TCP protocol. Okay, for example, I can click my like right button and then go to inspect. And I can, in the browser, there is a network tab, which shows like all coming and going packets through the network. You can, let me just zoom it. And you will see that, for example, I will open the first one, www.facebook.com. I will open this first one. So you see that, so remote address, it means Facebook's IP address is this one, this Facebook IP address that I visited. This is the port number, the application that is running on Facebook server that will, which runs on this port. I send the GET request on HTTP. GET means that we want to receive something. In this case, we received an HTML page. Okay, HTML usually has a method, has a URL, which we will talk about this domain names next lecture. The HTML also has some headers, which we call, for example, request headers. Whenever you request some data, you send some headers. Headers just means that, for example, let's say you request doner, but you don't want a lot of mayonnaise. You say that mayonnaise az olsun. This is just small information, additional information. You send them along with header. For example, let's say accept language, for example. I say that I only accept this language. I don't accept any other language, for example. What else do we have? For example, I say that I prefer light theme. Whenever you send me HTML and styles, just don't return me like dark HTML code. Return.
Can you change it?
Probably whenever I change my theme, let's go to my settings and go to general. Well, where was the appearance? I think, yeah, let me switch to dark mode and request again. Let me just clear my application storage. It didn't change anything, but let's say if the header changed. Request headers. Yeah, it actually changed to dark because the browser knows that I'm using dark mode. That's why browser puts it sensitive. Okay. Actually, I think whenever I log into Facebook, it will show me the dark mode. I don't think they have this. Maybe this page doesn't have dark mode, but the other page have. Okay. This dark mode is too dark. I don't like too dark. Okay, so HTTP is usually meant for web page. It is created by a person which is called who is called Tim Berners-Lee. Tim Berners-Lee. Yeah, he was just doing some research, which they should share some documents between researchers. That's why they created it. He's founder of World Wide Web. At the same time, he's also created the HTML. If I'm not mistaken, he has also created the first browser. Just to, because HTML is just a text. Okay, you need to show this text in beautiful way. Browsers are the tools that show this text in beautiful way. For example, whenever I request facebook.com, as a response, I get this text. Okay, this is HTML. This is HTML. This is just a text, but the browsers are the ones showing us this page. Okay, browsers are tools that parse this HTML and show it to us in a beautiful way. So
it means like you can use HTML for creating websites.
Yes, definitely.
Then why do we use JavaScript?
And just to add some interactions.
Like,
HTML is just for view. For example, whenever I click login here, I need to see this, I don't know, this message, for example. I need to see loading screen, I don't know. These are done by JavaScript. Okay? JavaScript does some logic inside the browser.
yes.
CSS, we also have CSS, which is just for colors and design. HTML is just structure of the page. CSS is view of the page. And JavaScript is the brain of the page, let's say. It's just some logic happens, JavaScript handles that logic. For example, you can listen to user events using JavaScript. For example, if user clicks this button, show this stuff. If user goes to another window, I don't know, show some alert, I don't know, pop up. Yeah, JavaScript just does those logical things, and HTML is just structure, and CSS is the style of the page. And all of these HTMLs are transferred through this hypertext transfer protocol. As you can imagine, whenever like I send a request to facebook.com, HTTP protocol is something like this, right? Let's say I'm sending, like I'm going to index page of like homepage of facebook.com. I do something like this. This is just how HTTP, this is how an HTTP protocol looks like. Okay. For example, whenever I send some request whenever I enter to facebook.com, this is actually what happens. I send this message, this small message to Facebook. And Facebook understands this HTTP protocol and responds me with some status code, which is a number, and responds me with some data, the HTML page. Take this text. Status codes, I think you are familiar with 404, which is called not found. You know, 404, 404.
Oh, yeah.
Yeah. No. This is just HTTP status code. Whenever I send a request to HTTP server, if it can't find this resource, it will return me 404, which means that I couldn't find that resource. Okay. I will send you some videos about HTTP. You can watch it at home. We will next lecture we will talk about domains, DNS, and stuff. We will also look at creating a web server using Python. Yeah. Just to go over quickly, this all happens as before, what we talked about before. For example, I sent this package to facebook.com, right? I first need to know IP address of the facebook.com. We will talk about it later. There is a DNS protocol, which is called, like, I need to convert this text into IP address. This is done through DNS. Then, if this package is very large, I need to send it over this layers, like from top to down. If this package is very large, this first TCP protocol will come and create this TCP handshake stuff, like three-way handshake that we talked about here, three-way handshake, create a connection with Facebook server. Then TCP will break this text into some small package and will send all of them to the Facebook server. Facebook server will respond with acknowledging that I received this. At the end, Facebook server will send us a HTTP package, like HTML, the response. And all of the things, of course, happens as well. For example, after transport layer, we have network package, we create an IP packet, then we create Ethernet packet, and this data goes through some routers and reaches the Facebook server, and it does the reverse of this process, and the response maybe is back some data. Okay. More about HTTP next lecture. Until then, I recommend you watch some Python videos, just gain some hands-on experience. Okay.